Do you know that this math solution can lead to a polynomial equation? Watch this video to the end and then you will find out. I will show you how to solve this question, which will end to a polynomial equation using two polynomial methods. Don't forget to give this video a thumbs up. Also, subscribe to my channel kindly for more unique mathematics solutions. Now, before we delve straight into the solution of this question, I want you to note two things: that 12 can be equal to 4 multiplied by 3, right? And then 8 can be equal to 4 multiplied by 2. So if we bring them into the equation, we'll have x to the power of 4, right? All to the power of 3. And this will be plus x to the power of 4 and all to the power of 2, and this will be equal to 80. Great. So I've not changed anything. I only interpolated the figures. Now from that expression, you can see we have x to the power of 4 and x to the power of 4. Why not we simply say x to the power of 4 be equal to y? If we do that, we'll simplify that equation. So we'll have y to the power of 3 plus y to the power of 2 equal to 80. I can see a polynomial equation being born. Great. Now, if we simplify that further, we are going to have y to the power of 3 to subtract 80 from both sides plus y to the power of 2 minus 80, and this will be equal to 0. Great. So this is a polynomial equation. Now from this point, I'm going to show you two unique methods you can solve this polynomial equation. Now let's use the first method. From the first method, I want you to note that if you have negative 80 can be equal to negative 64, right? Minus 16. Now I'm using this because this is factorizable and this is also factorizable. If we do that, that solution will now give us y to the power of 3 plus y to the power of 2 minus 64, right? Minus 16, and this will be equal to 0. Great. Now, having arrived at this, we also want to bear in mind one straight point. And what is that point? That 64 can be equal to 4 to the power of 3, right? Good. And if we have 16 can be equal to 4 to the power of 2. So you see that expression can be factorizable. So we'll have y to the power of 3 plus y to the power of 2 minus 4 to the power of 3 minus 4 to the power of 2, and that will be equal to 0. Great. Now let's simplify this. I'm going to collect the like terms such that y to the power of 3 will relate with 4 to the power of 3, right? And then we'll have plus y to the power of 2 will also relate with 4 to the power of 2, and this will be equal to 0. Now let's cast our mind back to what we call an algebraic formula. In that algebraic formula, what do we expect? We have a to the power of 3 minus b to the power of 3. This can be equal to a minus b, right? And this will give us a square plus ab plus b square, right? Good. And then if we have a square minus b square, this can be equal to a minus b, and then we'll have a plus b. Great. Now having these two quadratic equations, I want you to also these two algebraic formula, I want you to note that a from our expression can be equal to y, and then b is equal to 4. Now let's substitute these two expressions into that polynomial expression. If we do that, we'll simplify that expression to now become, that expression will now give us, the first part of that expression will have y minus 4, right? That's for a to the power of 3 minus b to the power of 3, and this will multiply y squared, right, plus 4y, right, plus 4 squared. Now let's go to a to the power of 2 minus b to the power of 2, which is y squared minus 4 squared. If we go there, we're going to have this expression to now give us plus 1 multiplied by y plus 4, and then we'll have y minus 4, and this will be equal to 0. Great. Now, having gotten this expression, we'll simplify further. Now recall that we have two expressions which is common, y minus 4 and y minus 4. So we're going to bring out y minus 4 as a common expression. And if we divide this whole part by y minus 4, we're going to have y squared plus 4y plus 16 left, because 4 squared is 16. Now if we divide this whole part by y minus 4, we are going to have plus y and plus 4 left, and all this will be equal to 0. So what do we have? This whole equation is now going to give us two equations. The first equation is y minus 4 equal to 0, and the other expression is y squared plus 4y plus y is going to give us 5y, right, plus 16 plus 4 is going to give us 20, and this will be equal to 0. Great. So we have two expressions, y minus 4 equal to 0 and y squared plus 5y plus 20 equal to 0. One linear, one quadratic. So what do? We are going to solve the linear and likewise the quadratic in order to find the three factors that we must get when solving a polynomial equation. Now let's go to the linear. From the linear, we'll have our y minus 4 to be equal to 0. We'll add 4 to both sides. We'll have our y minus 4 plus 4 to be equal to 0 plus 4. While this clears this, our y will be equal to 4. So y equal to 4 is the first solution to that exponential equation. Now the next thing we will do is to solve the quadratic equation. And from that quadratic equation, we are given that our y squared plus our 5y plus 20 is equal to 0. Good. So before we solve this, we want to find out the discriminant of this value. The discriminant will help us find out if the solution to this quadratic equation is going to be is going to give us imaginary solution or real solution. Now to find the discriminant of this value, we'll find out that our a is equal to 1, our b is equal to 5, and our c is equal to 20. So if we substitute that into the expression, the value of the discriminant will now be equal to 5 squared minus 4 multiplied by 1 multiplied by 20. So this is going to give us 25 minus 4 times 20 is going to give us 4 times 20 is going to give us 80, right? So if we simplify that, the value of our discriminant will be equal to 25 minus 20 will give us a negative 55, which we know is less than 0. So since 55 is less than 0, that means whatever solution we get from solving this quadratic equation will definitely give us an imaginary solution. So no real solution for that quadratic equation. As a result of that, we are going to neglect this solution. So the only real solution we'll have is y equal to what? Y equal to 4. So if y equal to 4 is the only real solution to that polynomial expression, the next thing we'll do is to substitute the value of y equal to 4 into that original expression. Recall we say x to the power of 4 is equal to y. So let's substitute the value of y into that original equation. X to the power of 4 equal to y. So if we have x to the power of 4 to be equal to y, which is 4, let's simplify this. If we simplify this, we are simply going to have this solution to become x to the power of 4, subtract 4 from both sides, this will be equal to 0. So this is going to give us x to the power of 2, right, multiplied by 2 minus 2 to the power of 2. All this is because 2 to the power of 2 is equal to 4 and 2 multiplied by 2 is equal to 4. So we've not changed anything. So from that expression, those two expressions will now be equal to 0. Now applying a law of an algebraic formula we have earlier on, x to a to the power of 2 minus b to the power of 2, this will be equal to a minus b, right? And then we'll have a plus b. From this expression, a will be equal to x squared and b will be equal to 2. So if we apply that expression there, we're going to have that equation to now become x squared minus 2, right? And then we'll have x squared plus 2, right? And this will be equal to 0. Great. So having seen this, we are going to simplify that expression. So x squared minus 2 will be equal to 0, as well as x squared plus 2 will be equal to 0. So from this expression, we will have x squared, if we add 2 to both sides, to be equal to what? 2. And if we simplify that further, we are going to have the square root of both sides. If we take the square root of both sides to clear the square, we are going to have this to become plus or minus the square root of what? 2. So if square root clears square, we'll have x to be equal to plus or minus the square root of what? 2. Let's come to this other side. X squared, if we subtract 2 from both sides, will be equal to negative 2. Great. So if we take the square root of both sides, we'll have x squared to be equal to plus or minus the square root of negative 2. Now, if this clears this, x will be equal to plus or minus negative 2 multiplied by the square root of negative 1. So if that gives us 1, square root of 2 multiplied by negative 1, and recall that negative 1 is equal to imaginary. So x will be equal to plus or minus square root of what? 2 imaginary. Now, because this solution is not a real solution, it's an imaginary solution, we are still going to what? To neglect it. So the only real solution we have for x, real solution we have for x is equal to square root of 2, or x can be equal to negative square root of what? 2. So these are the only real solution for x that satisfies that exponential equation we are given above. What a lengthy solution it is. Now, if you want to see how to solve this polynomial equation using the normal polynomial method, let's bring down the polynomial equation. And what is the polynomial equation? Y to the power of 3 plus y squared minus 80 equal to 0. Now let's bring it out. If we bring it out, you are going to find out how we use a simple method, the normal polynomial method, in solving that question. The question we have is, we have y to the power of 3 plus y squared minus 80, and this is equal to 0. So using the normal polynomial method, if you are given this question, what you need to do is to find a value of y such that once you insert it into this equation, you are going to have the equation to equate to 0. Now let's assume that our value for y is equal to 4. So we will have our 4 to the power of 3 plus 4 to the power of 2 minus 80. Is it going to give us 0? Let's find out. 4 to the power of 3 is going to give us 64. We are testing. Plus 4 to the power of 3 is going to give us 16 minus 80. If you resolve this, you are going to have 64 plus 16 is going to give us 80. And then 80 minus 80 is equal to 0. Great. So that tells us that that question, or this solution y equal to 4, is a solution, is one of the solutions to that polynomial equation. So this can become y minus 4 equal to 0. That's the first solution to that exponential equation. Now, to get the other two solutions, we need to find the quadratic formula. Now, to find the quadratic formula, all you simply need to do is to divide this whole expression, the original polynomial expression given to you, which is y to the power of 3, right, plus y to the power of 2 minus 80, divided by the first value you have gotten, that is y minus 4. Now let's start off with the division. If we start off with the division, you're going to find the quadratic equation such that if you simplify it, you get the other two factors. So y divided by y to the power of 3 divided by y is going to give us y squared, right? If that gives us y squared times y is going to give us y to the power of 3, and then y squared times minus 4 is going to give us minus 4y squared. So we're going to subtract this. If you subtract this, you have this to become 0, and y squared minus 4y is going to give us a positive 5y squared, and this will become minus what? Minus 80. Now 5y squared divided by y is going to give us a positive 5y, right? So 5y times 5y is going to give us 5y squared, right? Good. And then 5y multiplied by negative 4 is going to give us a negative 20y. So what do we do here? We are going to subtract this, and if we subtract this, this is going to give us 0, while this will give us plus 20y minus 80, right? So we're going to simplify this further. Now if we simplify this further, what is this going to give us? 20y divided by y is going to give us 20, right? So we are going to bring this down and then write what? 20 here, plus 20. Now plus 20 multiplied by y is going to give us plus 20y. And then we'll have plus 20 multiplied by negative 4 is going to give us a negative 80. So we are going to subtract this expression. While this gives us 0, this is going to give us what? 0, because minus 80 minus 80 is going to give us minus 80 plus 80, which is equal to 0. So you see, the quadratic equation we'll have is this, which is what? Equal to 0. And when we solve this quadratic equation, we are going to get the other two values or the other two factors to that polynomial expression. So you see, this is the way you can solve this equation, the polynomial equation, using the normal polynomial method. I know you did enjoy watching this video. Don't forget to give it a thumbs up, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.